Good morning, everyone. As you know, due to the lockdown conditions, we could not complete our syllabus in the classes, and we also know that there could be examination in the month of July. So I have decided to teach you while you guys stay at your home. Little info here. We have done up to alcohols in the ninth chapter of the organic chemistry. So today our topic is phenol. I will give you today the introduction to phenol and phenols. Plus, I will teach you the IUPAC and common naming of the phenols. Besides, I will also teach you how to prepare it, and will also give you some assignment so that you can do at home. I will highly appreciate if you guys fare your work as you normally do, which we do today. You can share that in the back to me through the WhatsApp groups, so I can check how the copies are fair. So let's start our lecture. Our topic today, as you can see, phenol. We are doing chemistry 2, and it's the ninth chapter, and the topic is phenol. Now, if you know alcohols, as it was our previous topic, they have a general formula ROH or CN H2N plus 1 OH. Now, the phenols are somewhat similar to the alcohols because they both share the same functional group. And of course, this is OH. The difference between alcohols and phenol is that in the alcohols, the hydroxy group, the OH hydroxy group, is attached to an alkyl group like methyl or ethyl, let's say CH3OH. This is a common alcohol. It's called methanol, as majority of you might already have guessed. C2H5OH. This is, ethanol, which was our previous topic as well. Now the phenols are having the similar functional group, which is the OH. The only difference is this OH is not attached to an alkyl group. It is attached to a benzene ring. So benzene ring, it's a 6-membered ring of carbon atoms with the alternate single and double bonds. You can also show it like that. Now, if the benzene is substituted with a hydroxy group, now this is called phenol. So I hope you understand the phenol, by definition, is a benzene ring which is mono substituted with a hydroxy group. Now this hydroxy group, as you know, is ring activators. If you know this, OH is ring activators. That means the presence of hydroxy group makes the benzene ring electron rich. The electron density over and under this hexagonal ring is basically much higher than benzene itself. So phenol is more important. Phenol is more used. Phenol is industrially more important as compared to benzene due to greater electron density, and that is because of the presence of the hydroxy group. If you know, the hydroxy group, the O oxygen, it contains two extra, we can say, lone pair of the electrons. So the presence of the OH group will obviously make the electron density of the benzene ring higher, and it will attract more electrophiles. It will, presence of the OH group will attract more electrophiles. This way you can get many other products from phenol. Even that phenol is a compound. It's also called carbolic acid, but it's a very old name. It's a single compound. But there are so many compounds derived from phenol that now we consider phenol as a family of organic compound. So there are so many other phenols, and they are very much reactive than benzene. So industrially, commercially, very much important. I hope there are some differences between benzene and phenol. One is phenol is more reactive than benzene. The reason I told you, benzene is also acidic in nature. It can donate a proton. This also makes phenol more acidic and more reactive than benzene. If you, for example, have a phenol and you add a base, let's say sodium hydroxide to it, then the acid-base reaction in which H goes to the OH, and it is because of the charge distribution here, it forms, of course, water, and this group ONA is attached to the ring. This is called the sodium phenoxide. Now you can see this is an acid, this is a base. It forms salt and water. So the acidity of phenol makes it more reactive as compared to benzene. So I hope you understand the general introduction to the phenols and how they are different from benzene, and it's of course single compound, but it can react pretty fast and make new compounds, and obviously it has become a family of the organic compounds. Now I will jump towards the next, which is the naming, how we name phenols, or we can say nomenclature. As you all know, IUPAC, International Union for Pure and Applied Chemistry, sets many rules for naming of the organic compounds. So as if there are rules for many families, there are also rules for phenol. Now, if you just go to simple phenol, there's no issue. It has a common name, phenol. But this basically is monohydric. Now, monohydric means it contains one OH group. So now the phenols can come with more than one OH groups. They have special names. They don't have the IUPAC name, but they have common name, and it's very much important for us to remember them, because they are important organic compounds in industry and in our life. But when it comes to annual examination, we see at least one or two questions or one or two naming from the common phenol, which are dihydric or trihydric. Now, this is a monohydric phenol. Let me tell you a few dihydric phenol. Dihydric, that means with the two hydroxy groups. Dihydric phenols. As you can see, this is the benzene ring. This is cyclohexane. Now it's the benzene ring, and this is the phenol. If the second hydroxy group is present at number 2, or it's called the ortho position. This is 1, 2, 3, 4, 5, 6. Now 2 and 4 is called ortho, 3 and 5 is called meta, and 4th is obviously called para, and we have learned this. Now if the second OH is present at the ortho position, this has a common name, catechol. It is commonly called catechol when the second OH is present at the ortho position. I hope you will remember it, write it in your copies and remember it. If this OH is present on the meta position, which is not 2 but 3, I should write it here, 1, 2, 3. If it's on 3, this is the, as you know, cyclohexane. Now this is benzene, and there's a phenol, and that is our second OH on the meta position. This is called resorcinol. Resorcinol. In this case, the second OH is present on the position number 3. The other one, in fact, the last one after this is when the second OH goes to number 4. And this is called hydroquinone. Now, hydroquinone is a compulsory part of Fair and Lovely and most fairness creams. So, as all phenols are important industrially and for consumers, hydroquinone is the one which we use in many fairness creams. These two are the dihydric. Now, you might be thinking, what if the second OH goes to this position? Now, this position is similar to this. So, if OH is here or OH is here, it remains as resorcinol. If OH is here or if OH is here, it still remains catechol. Now, in the paper, if you see two OH groups side by side, like this orientation can be anywhere. Like these two OH can be here or here. This will stay catechol. If there's a gap of one carbon anywhere in the ring, that will be resorcinol. And if there's a gap of 2 carbon, the position of OH can go anywhere. Like this is hydroquinone. Let me make you another hydroquinone so that you can not get confused in the examination. This is a benzene ring. I made with a different orientation. If one OH goes here and the OH goes here, now this is same. It's not catechol, it's not resorcinol, it's hydroquinone, because from this carbon it's like one, there are 2 carbons in between. So the next OH is on the 4th carbon. So these are the dihydric phenols. And we should remember the names and write them and show to me later on in your copies. There's one trihydric phenol. This trihydric phenol has 3 OH groups. It's obviously a benzene ring with the basic phenol, and it has like this, in this orientation. This is called pyrogalol. Now, pyrogalol is also an important compound in the medicines and in the photography industry. When they used to wash the negatives into positives, then the pyrogalol was used to do it. So these are some monohydric and dihydric and trihydric. There's one monohydric phenol, which is the basic phenol. These phenols have other names and they are different by use. It's not necessary that only OH groups can be substituted. the phenol can have other groups as well. For example, this is a phenol, this is a cyclohexane, and now it's a benzene, and this is now phenol. It can have a methyl group. Now this is interesting. We number it from the OH group, as you guys know, 1, 2, 3, 4, 5, and 6. Now it's called 4-methyl phenol. There's no gap here, so 4-methyl phenol. This is very simple. Just as the naming of alkane, we just number the ring rather than the number of the chain, and we can simply name it. If this is you also know it's called this is a 4 is a para position, so it can be called as p-cresol or p-methyl phenol. Now obviously this one is IUPAC, and these two are the common names. So 4-methyl phenol was called cresol. So if this is number 4, it's p-cresol. Now can you guess if this is a p-cresol or 2-methyl phenol? Can you guys right now quickly guess the name of this compound? I'll give you a minute. So I guess you've guessed right. It's yeah, you're right. 2-methyl phenol. This is the IUPAC. Now tell me about the common name. If this is p-cresol, what is this going to be? Yes, O-cresol. O-cresol, O for ortho. Any other name? Yeah, ortho-methyl phenol. Now let me tell you here, there is no M. If you are guessing that the next I'm going to give you M-cresol or 3-methyl phenol, since the OH is an ortho-para direction group. So in that case, you never have a meta product. So don't expect that. Now, where there's a methyl, there could be ethyl. There could be simply, I should make it for you. Now, this is a benzene ring, right? This is OH. How about I add here CH2, CH3. Now it's a similar thing. 1, 2, 3, and 4. Now this is 4-ethyl phenol, as it was 4-methyl phenols. Just simply, they could be 4-propyl or 2-propyl or any alkyl group that you can write. But first you write the number of the carbon where the alkyl group is attached. Then you write that the way you name it. And it's pretty much simple because we've been doing it before. There can be other groups as well. Since the OH is an activator group, it can invite any electrophiles. It can be chlorine. So if it is 2-methyl phenol, what is this? Yep, 2-chlorophenol. That's right, 2-chlorophenol or O-chlorophenol, this is the name. And how about this guy? If you can help me. NO2, NO2, NO2. Now this time, you see 1, 2, 3, 4, 5, and 6. You see substitutions on 2, 4, and 6. So if you guys know the previous methods, we write all these numbers. 2, and then we give a comma, and then 4, give a comma, and then 6, then hyphen, trinitro phenol. Many of you might have guessed already, trinitro. If there were 3 chlorines, it could be trichloro. If there were 3 methyls, trimethyl, and so on. Here, I want to mention that this compound is called picric acid. It's a very strong antiseptic, and it is a picric acid. Now, these are some naming, but I must also tell you that sometimes 2 rings are attached. Like, for example, if this is benzene, if there are 2 rings, This is called naphthalene. And if naphthalene has an OH group, then this is going to be called naphthol. Yes, yeah, this is naphthalene, this is naphthol. This is 1, 2, 3. So this is 1 naphthol, or you can say alpha naphthol. If it comes on second one, it's called 2 naphthol or beta naphthol. Now naphthalene, naphthol, there are other. For example, what if there are 3 rings? It's called, let me make the rings first. It's called anthracene. Now, naphthalene, naphthol, double ring, naphthol, OH, naphthol, 3 rings, anthracene. Can you tell me if the 3 rings have the OH? Anthracol. That's right, anthracol if we have OH here. And there are many other ways to make it and name it. If the 3rd ring is like this, it is called phenanthrene. And if phenanthrene has OH, it is called phenanthrol. This way there are many compounds of the phenol which you can check online, but this is what in your textbook which mostly it has. So a little bit review here. Phenols are basically aromatic compounds with the hydroxy group. Okay, they're just like alcohols, but alcohols are mostly liquid, the first one, and they are aliphatic, and phenol is aromatic, and it is basically solid. Physical properties which we will discuss later on in the next lecture, which will be obviously tomorrow now. But before we end up this little session, I want to give you some assignment and homework. So homework is basically, let me do it with a red pen so it's more dangerous for you. One is you to write the introduction and naming of the some names of important phenols. Number 2 is in our textbook, if you can refer to your textbook, and it's page number 212. The question number is 3. Remember, we have done this question up to, let us say, 7th parts. So from 8th to the 13th, yeah, I guess 13th. These namings are from the phenols. So you gotta do what? You gotta write the introduction of the phenols and write some names of the phenols in your copy, and you have to do the nomenclature of these compounds and show me a copy back into the WhatsApp groups. I hope you all are doing well, and I hope this session will go well. We have 1 or 2 months. We will stay at homes and we will continue our lecture. Tomorrow I will be sharing with you the preparation of phenol, and so on. As we get used to it, we will extend the syllabus each day. Thank you very much. Stay safe, stay home, and study. Thank you. Goodbye.